It's a pleasant morning again. Last video we have discussed the different characterization of forces, and we will just have a small recap. We said that forces are characterized into three things. Number one is the point of application, this one. Number two is the magnitude. If this is 30 Newton, then this is 30 Newton. That is the magnitude. And number three is the line of action, which is the direction of the force, the line of action. It is a representation where the force can freely move. It is just the extension of the line of force. These three are the characterization of the force. And also we have discussed the difference between the concurrent forces and non-concurrent forces. Now we are going to give a further definition of a force. Now, force is an abstract. It is an abstract thing. That is the first definition that we have discussed in the first video. Another thing about force is this is a vector quantity. Vector quantity. Now, what is a vector quantity? And suppose you have heard or you have learned vector quantity previously. The opposite of vector quantity is a scalar quantity. Now, what does these two mean? When we say scalar quantity, if I say distance, let's say I say distance, let's say I say 30 kilometers. When I say 30 kilometers, I just said 30 kilometers, but there is no associated distance. I just described I walk 30 kilometers. I walk 30 kilometers. I just represent the distance by 30 kilometers. There is no associated direction. The same also if I say volume. Let's say the water was spilled and the amount of water spilled is 8 cubic meters. Now when I say 8 cubic meters, it is just a quantity because the scalar quantity is the main subject here. When I say 8 cubic meter is the water that was spilled, I'm just referring to the amount or the quantity, but there is no associated direction. If I say mass and I say the weight of the no, I'm not going to say weight, but let's say the amount of matter inside a particular body is 40 kilogram. I just refer to the amount of particle, the weight, but there is no associated direction. Now, the opposite of scalar quantity, it is not an opposite actually, but another version or an upgraded version for scalar quantity is what we so-called vector quantity. Now, what is the difference between the two? This vector quantity, sometimes called displacement, which is related to distance. When I say vector quantity, if I say I walk 30 kilometers, but we just said that 30 kilometers is a scalar quantity. But if I add due east, you can see the difference. I said I walked 30 kilometers due east, meaning there is an associated direction. I am referring to a particular direction. I walked 30 kilometers due east. In the first example, in this one, I just said 30 kilometers. We don't know which direction. But for the second example, we just say I walked 30 kilometers and there is a specific direction. It was east. When I add a direction, due east, with a scalar quantity, now the combination of these two is a vector quantity. So the combination of direction and a scalar quantity is called a vector quantity. So this is the difference between the two. For example, mass. If the 40 kilogram mass, let's say we have 40 kilogram mass multiplied by 9.81 meters per second squared, and I guess you already know what does this mean. This is an acceleration due to gravity, and so we can compute the value is 392.4 Newton, because when we multiply kilogram in terms of meters per second squared, it is just equivalent to Newton. Now, what does this mean? 40 kilogram is just a quantity. It doesn't have any sense or direction, just like in this first example. We just said 40 kilometers, that is the weight of the man. But when we multiply it with this one, this is acceleration due to gravity. Acceleration has always had a sense or direction. We know that the gravity is always pointing downwards. Downward. The moment that we add or we combine a quantity with a direction, 40 kilogram, with a direction downward, the moment we combine these two, that is when it will become a vector quantity. So therefore, Newton is a vector unit. Okay, Newton is a vector unit. That's why force, as much as our example previously, most of the forces that we have thrown, we said 90 Newton, which means Newton is a vector quantity, therefore these forces are vector quantities. So in other words, force are vector quantities. Force are things that has magnitude. Okay, we have, let's say, 110 Newton. This is the magnitude, this is the number. But as you can see, the arrow is a representation of direction. When you have an arrow, when it is pointing towards something, it has a direction. This is what we so-called vector quantity. Now, how do we further understand the difference between vector quantity and scalar quantity? Suppose we have this kind of example. Suppose, let us erase this one. So let's say we have an example. We have a scalar. Okay. Suppose I'm going to add scalar quantities. Let's say if you try to add 30 kilometers with 50 kilometers. If we sum them, these are scalar quantity, no direction. So we would say 80 kilometers. And you would be proud to yourself to know that it is just equal to 80 kilometers. It's so easy. It's just so boring. You know, you might say this is just an elementary addition. If I say I wanted to add 40 kilogram with 120 kilogram, you would immediately say it is just equals to 160 kilogram. Easy as pie. Now, in other words, what can we deduce from this? When we add scalar quantity, we just use the operation of addition. In other words, when we are adding scalar quantities, we just use addition operation. It's as simple as that. But this is the catch. When we say vector quantity, if I say 30 kilometers due east, let me just use east, which means there is an associated direction, and we wanted to add with 50 kilometer due west, and the west is a direction. This is a vector quantity, and this is a vector quantity. If we add two vector quantities, what might be the possible answer? I'm asking you, what might be the possible? Just guess. Take your guess. Now, some of you might say, okay, it's just 80 kilometer, and since this is on east, we just write it here, and west, we just write it here. Is this the correct answer? Congratulations, my friend. Wake up. This is completely wrong. Because the difference is that the vector quantity cannot be just added using normal addition operation. we cannot do it like what we did in scalar quantity. You cannot do this. Addition operation is not applicable in vector quantity. Unlike in scalar quantity, we can just simply add them and we would find the final answer. Okay? So vector quantity doesn't apply to addition operation. So for the next video, we are going to discuss how can we add vector quantities. And there are so many ways. And that is the beginning of how we are going to use calculation and computation. This is the end of this video.